Hello, my name is Nathan Dunnigan, and this is my Physics 2212 Lab 2 Lines of Charge. The purpose of this lab was to create computational model of two pieces of charged tape exerting an electric force on each other. The charge of the tape will be distributed along the length of the tape, which is the opposite of what we did last lab using point charges. And we were asked to determine the magnitude of the charge on the top piece of tape, which will be discussed later on. The models and principles used were Coulomb's law to calculate the charge on the piece of tape, which is seen to the picture in the right. The force due to gravity, F equals mg. Newton's second law to determine the two forces. An electric force, which is equal to the electric field times Q. And then superposition, which is adding up all the electric fields. And the model used was each tape is modeled as equal segments with their own charge. And then using superposition, the segment forces were added up to find the net force. Some key assumptions were that the system was the piece of tape and the surroundings were my hand, earth, everything else in the room. And some assumptions were ignoring air resistance, assuming each U-tape has equal charge is evenly distributed, and that the tape can be separated into these pieces, which is seen in the picture to the right, which shows the separation of charges and superposition. A preview of some results is that the gravitational force equals the electric force, which is equal to 1.96 times 10 to the negative 3 newtons, and that the Q calculated in this lab was 2.166 times 10 to the negative 8 coulombs, and that superposition and line charge model is more accurate, which I'll talk about later. This is an experimental recap of last lab where we had two pieces of electrically neutral tape with the third piece flat down on a desk, and tape B was stuck to the base tape and ripped off in order to create a charge, and then it was held near several different objects to determine the charge, which resulted in U-tape B being negative, meaning it lost electrons, and that tape B moved when tape A was 0.0192 meters under it. And we discovered that the mass was 0.0002 and the length was 0.2 meters, and that Q was 8.96 times 10 to the negative 9 coulombs. So to get into the computational model for this lab, I started off with my physical constants and then adding in my lab 1 results that I just discussed. And then I also added the electric field equation that we used in lab 0. I then included the given line of charge function, which divides the tape into n amount of pieces and creates the spacing in Q for each segment of the tape. And then I added the vectors for the top tape and bottom tape, and I used the distance measured from last lab as the y component for the top tape. And next I am showing some forces on the top tape, and then the for loop, which was used as superposition as I mentioned earlier, and then finally the computational model ends with the gravitational and electric force to then determine the total net force. And this is my first visual output from the computational model, with us having a force upward, the electric force in white, then the gravitational force downwards. The green arrows are the electric field with the n equals 50 pieces. The red dots are the top tape, which is the system, and then the blue dots are the bottom tape. And the Q value used in this model was the one calculated from lab 1. However, the magnitudes of electric force and gravitational force are not equal, so this concludes that Q from lab 1 is inaccurate. So then I redid the process, and I used the equation derived in class for electric force on a point charge by line of charges, and then I used some guessing and checking to determine the new Q value of 2.166 times 10 to the negative 8 coulombs. This more accurately describes this interaction, as it shows the electrical and gravitational force being approximately equal, as seen in the picture to the right. And to talk about some possible sources of error, there are probably less because it is all computational in this lab. However, some error still applies from lab 1, such as the rounding or measuring in the experiment in lab 1, or other forces acting on the tape. And then there aren't many similarities, differences between lab and computational for this lab, as it is all computational. However, this is definitely more precise, as it evenly distributes charge rather than treating tape as a point charge. And now to answer my what if questions. The point charge, I had a Q value of 8.96 times 10 to the negative 9 coulombs from lab 1. And then as I just discussed, we had a Q value of 2.166 times 10 to the negative 8 coulombs in this lab, which is a 141% difference, which is very significant, showing that there is a big difference in these two labs. And I believe that there are differences because different calculation methods were used, and I believe the line charge model is definitely more likely to be real, as shown in the previous slides, where gravitational and electric force magnitudes are equal. And then finally, to conclude, the line charge model is more accurate and precise. The more pieces in the line charge, the more accurate the answer will be, and most things, including these pieces of tape, are better modeled as line charges in real life, with each piece having an equal charge.